Alright, and here we are in series RCL circuits. We're going to look at calculations for this one. We are going to start with inductive reactance. So we'll take the values for our formula, 2 pi, frequency, and inductance, multiply them all together, and we get an ohmic value of 24.18 k ohms. And then we are going to do capacitive reactance, and we use the formula for that, and we get 4.2 k ohms. Alright, now we are going to put those into our impedance formula. So you will notice that you have your 10k, and that is the resistor's value. So that's the first one that's there. Now that second one you notice has 19.98k. That is actually inductive reactance minus capacitive reactance. So it actually doesn't matter whether you take capacitive reactance minus inductive reactance. In other words, it doesn't matter if the value is positive or negative, because when you square a negative value, you get a positive value. So it doesn't matter which you take from which. It's just a little easier to take the bigger one and subtract the smaller one. All right, and then we just do those the way we have been using for our Z formula. That's really the only change for our Z formula. And we get a total impedance of 22.34 k ohms. We do current next. We take our voltage divided by impedance, and we get 2.01 milliamps. And of course, next we're going to look at voltage. So the voltage for our resistor is resistance times current, and it gives us 20.1 volts. And then we look at the voltage for our inductor, which is the inductive reactance times current, and that gives us 48.6 volts. Again, now we look at voltage for our capacitor, which is the capacitive reactance times current, and we get 8.44 volts. Now, obviously, just like before, you can't just add all this stuff together to get 45 volts. So what you have to do is put that into your voltage formula, and it's very similar to your impedance formula in that you take the voltage of one and subtract the voltage of the other and then square the difference. So you have to subtract the one from the other before you square it. So for this formula, we would have 20.1 volts, which is the voltage of the resistor, and then if we take 48.6 volts and subtract 8.44, we get 40.16 volts. And then, of course, we square both of those and then take the square root, and you should come within hundredths, maybe tenths of 45 volts. All right, and that's all there is to it. That is a series RCL circuit calculations.